LeetCode question number 34. Find the first and last position of an element in sorted array. This is medium question, and then it has a lot of thumbs up. So you must check it, this question. Okay. Given an array in integers num, sorted in ascending order, find the stems and ending position of a given target is value. Your algorithm runtime complexity must be in order of big O L log n. That's right. That is binary search. We need to implement with binary search. If the target is not found in the array, return -1, -1. Let's check the example 1. At this time, 8 is here, right? So start point is 3, and then end point is 4. And then example 2, 6, but there is no 6 at that time. -1, -1. How are you gonna do? Okay, let's the brainstorming. There are the binary search library in Python, and then it has two operations. First is bisect left, and then another is bisect right. Sec left, and then second is sec right. And then this one, first is, okay, there are some value here. When you find this bisect left, we return exactly this value. The reason is the bisect left is return the left value here of the target, and then bisect left is target, and here then this is previous right index. So when you put the value, and then it will return here. So if we put here and then this one here, finally the index is same as the current target index, because that is increased, and then index is same as previous one, right? But the right is a little different. When we the right, and then we return this value right side, so this one. So we return this one. So when you use this one, we easy to get this one. The reason is this one just return this one, right? And then this one the next index of the we looking for, we just deduct -1. Does this make sense? So we will use this pattern. First, we needed to do some edge case. If not nums is null, which one we needed to return? That's right, -1, -1. And then if, okay, this is the first one, I will use bisect left, and then put this num and target. And then let's the edge case handling. Is there any case the target is not in nums at that time? Maybe nums 1 must be different to the target, right? In this case, we needed to return -1 and then -1. Another case is this one is the out of boundary. That is that we cannot find it. Maybe index is here. So one is length of nums, or then okay, but when we found the target number, there are no edge case, right? Because find one is just one over the many. So at this time we just return 1, bisect sec right nums and target -1, because it this one return 10, so we need it to minus 1. Does this make sense? Okay, let's check the code. Okay, looks good. Let's submit. But actually this one is not enough, right? So maybe I think the interviewer also want to see I able to implement binary search or not. So I recommend you please don't stop here and then ask to interviewer, can I implement the bisect left and right? And then if the interviewer say yes, at that time we could implement bisect left and then put nums and target. And then left is 0, right is maximum index of the array, so nums minus 1 because index start with 0. And then while left is right, left is smaller than right, and then get mid value. And then if nums mid is smaller than target, we need to change left is mid plus 1 as right is mid. Then return left. Then second is bisect right, and then nums target. Then left also 0, right is length nums. Because we make the right position is if nums is 1, 2, 3, target is 3, means we need to return index it to here. Because we needed to return the index, the next of our target. Does this make sense? So that is the reason we needed to write is increase 1. This now is bigger than target, and then right is must be mid, and then else left is mid plus 1. Return left. Okay, let's check the code. Now we use custom made. Okay, looks good. Okay, let's check the complexity. Time complexity is this one constant, this one log n, this one constant, this one also log n. So finally time complexity is log n, and the space complexity is constant because we do not use any data structure. Thank you.